then write it if f's conservative, then line integral is independent of path. Okay. Okay. So it's important to check whether these are useful. So then you'll get back up to 5.5 or 6.5 or whatever pretty quickly.
I'll be working on it.
Okay, great. All right. So what this means is you have one closed curve, C1, another closed curve, C2, that both go in the same direction. So going up to here from A to B along C1 and going back along C2, so minus, will give you 0 in that case. Therefore, the two line integrals going in the same direction from A to B here, from A to B here, must be equal. So, yeah, there are certain problems on this test that are definitely rigged in the sense that they're all doable. No, they're doable anyway. If you do them the right way, they're easily doable.
I feel confident about this one.
Oh, number 4? This problem? Okay.
I feel good about this one.
No, not about this number 4, just the number 4 in general. I feel comfortable about.
Well, I have number 4.
Sesame Street is brought to you by.
And the letter J.
Okay, so.
I like it by the value P.
All right. So I need to show that it is conservative. So. That would be the curl, really, in most real cases, if and only if the kernel of f is equal to the 0 vector. So that's how you check. So you do need to check this, and it's part of the problem. That to show that it is conservative. Once you do that, then you have a green light to find what f is. And that's where you use a method that was discussed in class. That so when we call this P, Q, and R, then that means that f, little f, x, y, z, is going to be the antiderivative with respect to x of P of x, y, z, with respect. So integrating with respect to x plus some function that only depends on y and z. That's unknown at this point. So you're just going to anti-differentiate that with respect to x, get g of y, z, and then that means that, okay, and we'll call this function, we'll call this h of x, y, z, whatever it is you get from here. So fy, which is hy plus gy, must be equal to q. Fz, which is hz plus gz, must be equal to r. So between these two, you can find out what this mysterious function g is. And so then at least you have the little left completely determined up to a constant. For some functions that are simpler than others, you might be able to kind of eyeball it and figure out this. Because this is one approach. The other approach you can take is pick a different function. Pick q. Integrate with respect to y, and then you have some function of only x and z. So you can start however you like, whichever is going to be easiest.
I have a question.
Yes.
Is that how you check the curl?
Oh,
or is that something else?
Okay, so, oh, you're checking.
Oh, that's what it has.
You're checking these.
Mm-hmm.
That's equivalent. So yes.
Okay,
Yeah.
so it counts.
Yeah, because
That one's good.
because py minus qx, that's one component of a curl.
Yeah,
Both
so
of
it
them.
has, they'd all cancel out.
Let's see how you did at number 5. Green's
I got
theorem.
a good answer for it, and nice, easy answer, so
Um,
I'm pretty good.
yes, it does work out
Very nicely.
uncharacteristically nicely. Yes.
Okay,
Uh,
I think I got it.
okay. So, yeah, because you're differentiating p with respect to y and q with respect to x. So if some variable is not involved and something turns out to be 0, well, that's just something that can happen from time to time. So, so in this case, your D is this triangle. So you just have to integrate whatever nice function you get here over this carefully, and so that would mean.
Oh, I did that.
Okay, all right. Okay, so we can put that in the W column for you. So, so that's how many you have right so far?
Yes.
Okay.
And that was also the answer that I got.
Oh, okay. I don't even know, so I just. Okay.
Split up into two. Because it's like, well, it's not.
Yeah, so it's not a whole lot to this one. You just compute the derivatives and integrate over region, and there you have it.
Hopefully I calculated the slope right this time though.
Oh, right.
I messed
Yeah.
that up on my last one. I made the integral easier.
I think no one actually fully got
Got
that
that
problem. Someone came like incredibly close
It
to
was
the
so
right answer.
frustrating. I was like,
Yeah.
I can do all the work, but I messed up the slope of the line.
Actually,
for
that's what a
one
lot of
part.
people did. Most mistakes were made in the setup.
Because like because you go from like the 3 to 2, and so I messed up which 2 I was looking at. Okay. No more chips.
Really? They're all gone?
No, I'm cutting myself.
Oh, you're cutting
off.
yourself? Okay. Okay. All right, so there's still plenty for you.
This is the one I got halfway through, and I got them to look very, very similar. I just can't connect the
this
two of
one.
them together.
Yeah, this is,
Another number 6.
as you can tell from my scratch work, a pretty fun one.
Well, I got like them to equal the same thing. I just can't figure out how to like explain it. Kind of.
Okay. F div G minus G div F plus G dot del F minus F dot del G. Now, I do need to explain some notation in this, which apparently did not cause a problem for you, but just to make sure for anyone watching this on video, because this is rather odd expression. Really what we have is, this is a scalar, and it's a function of x, y, and z, but it's still a scalar, multiplying the vector field f. Here we have a scalar also multiplying the vector g. And so what we're going to have here, this is going to be, first some more notation. I'm going to say f is equal to p, q, and r. And for g, I didn't like the letters I picked, but whatever.
LMN.
LMN, is that what you used?
Yeah.
Okay, actually that's a better choice because I picked u, v, and w, but then
That can-
you use look like these.
That's why I had to figure out.
Oh
3
man,
then.
I used to lose sleep up or having to be like, okay, UV, dang it, I can't read this professor's writing, UV.
Of course, since I have u and v's on my paper, it's going to be interesting, but I'll just have to not look at it.
It'd be neat.
Go for it. So,
I'm like so tempted to eat the chips because they're similar.
Girl, you got to.
No, I really don't.
well, you can do nutter butters instead, like you did last time.
I could. I worked my way from salty to sweet.
Yeah, you gotta cancel them out.
Girl, we don't tear up into these cookies.
I've already had 2 of these.
So g dot del is going to be equal to L differentiated with respect to x plus m different with respect to y plus n different with respect to z.
Wait, isn't that? I put it that that's just the
I don't know. Del.
div, the divergence, isn't it?
Um,
Because it's the dot product of L and N.
divergence of f is del dot f. But
Because
notice
it's
here,
reversed.
yeah.
Shoot.
You still got it to be equal though?
Well, because I made it that.
Okay, well,